Good afternoon, students. Now we are going to see about direction control valves. Which are used in pneumatic system. Okay, so there are various types of direction control valves. You can say 3x2, 5x2, etc. So what is this 3x2 direction control valve? Okay, so 3 refers to the 3x2, 3 ports, 2 position. And here 5x2, 5 refers to 5 ports and 2 position. Okay, so first we will see what is 3x2 direction control valve. And now you can see 3x2 direction control valve. Okay, here is the first port 1, 2 and 3, and this separates the direction control valve, so it is 2 position. And here again this is the first port, this is the second one, and this is the third port. So 3 ports, 2 position, and it is operated by solenoid valve, which is at the extreme end, refers to the how it is operated. So this symbol represents the what is the type of the valve. So this is solenoid operated 3x2 direction control valve. Similarly, if you see 5x2 direction control valve, okay, so this is 5x2 direction control. Here it is the first one, the second port, the third port, and the fifth port, fourth port, and the fifth one. And here this is the first, second, third, fourth port, and the fifth one. Okay, so where the fifth port leaves the working field to the atmosphere, where the first port is the block of the direction control valve. Okay, from second port, here we will be having a compressor or a pump. It sends a pneumatic fluid like air or working fluid to the system. And this 5x2, this 5x2 direction control valve, here it is separated. So this is 2 position, 5 ports. And this symbol represents the hand lever. It is hand lever operated valve. Okay, one side it is hand lever. The retraction will be by the spring. Okay, so this is about the 2 types of direction control. One 3x2 and the second one is 5x2 direction control valve. Now we will see how this 3x2 direction control valve is applied in a pneumatic system. Now we can see the circuit diagram of a automatic car park carrier, where as I told you, we are going to use 3x2 solenoid operated valve. That is 3 ports, 2 position solenoid operated valve. So this is solenoid valve A. Here we are having 2 solenoid valves. So this is solenoid A. Okay, so this represents the solenoid valve. One side we are having electric outlet, the retraction is by the spring. When this solenoid gets energized, the valve motion changes. Okay, so this pump, the symbol represents the pump. It will pump the air to the cylinder. Next, when the electrical signal is cut off, the automatic is done by the spring. Due to first the spring will compress. When this solenoid valve gets switched off, the spring pushes to this original position. Okay. This is the solenoid A, and this is the solenoid B. So this is the solenoid one B, and this is the double acting cylinder. This is cylinder, double acting cylinder, and this is piston, and these are limit switches. And this is the barrier. Now we are going to see how this barrier raises up and comes down when it is electrically operated. Okay. So when the coin is put in, this solenoid gets operated. So that the wall cushion changes. When the wall cushion changes, what will happen? This pump will, pump the air in this direction. Okay. So this cushion will come to this here. The cushion will change the direction of the work. So the air will pump to this way. So it moves towards the bottom of the piston. When it moves towards the bottom of the piston raises up. When the piston raises up, what will happen? The barrier raises up until there is a limit switch here at the top. There will be a limit switch at the top. So until this, the barrier will raise up. So the vehicle will move from one side to another side. So next, once the vehicle moves at that, what will happen? So this solenoid gets energized so that it will send the, it will change the position. When it will change the position, this pump will pump the air so that the air moves towards this direction. So it, pushes the cylinder down. So when the piston moves down, what will happen? It brings down the barrier down. So when it reaches the limit switch, the signal will cut off to this 3x2 solenoid. We are going to see about strain gauge. What is meant by strain gauge? Strain gauge are used to measure the deflection in a beam. Generally, there are three types of strain gauges. The first one is metal wire. The second one is metal foil. And the third one is the semiconductor. Okay, so there are three types of strain gauges: metal wire, metal foil, and semiconductor. As I told you, what is the strain gauge? Strain gauge is nothing but it is used to measure the deflection in a beam. For example, if you take this is a cantilever beam where one end say is fixed, other end will be free. When I apply a point load on the one end, that is W, there will be deflection in the beam. There will be deflection in the beam. What is this deflection? Will be find out by the strain gauge. So how it will be find out? So we will see the first step. So when we fix the metal wire strain gauge on this top of the beam, and one more strain gauge, that is strain gauge A, or this is the first strain gauge, this is the second one, and this is the second one, that is B. So these two are strain gauges which will stick like a stamp. They will stick like a stamp. The surface will be very much soft, so it will stick like a stamp to the any surface. So when these strain gauge A and B, which is fixed to the beam, when the deflection happens, it will measure how much deflection has been occurred when the point load is occurred. How this strain gauges will measure, I will tell you. Okay, we will see now how the strain gauges measure the deflection. Now first we will see the metal wire strain gauge, how it will be. So this is the image of the metal wire strain gauge. Okay, so this is the image of the metal wire strain gauge. Okay, so the wires, when it gets deflected, it will produce electrical resistance. And the wire, when deflection happens, what will happen? When the beam bends, the top of the strain gauge will get elongated. This strain gauge which is on the top will get elongated. And the bottom strain gauge will get compressed. Due to elongation or compression, the metal wire expands or compresses so that it will produce resistance. It will produce resistance. That changes resistance, that is del R is nothing but deflection. The del R is nothing but deflection. Now we will see this strain gauge. These two wires are connected to the Wheatstone bridge. Okay, these two wires are connected to the Wheatstone bridge. So this is the coil 1. This is 2, and this is 3, and this is 4. So this is called as Wheatstone bridge. This is called as Wheatstone bridge. When the wire gets elongated or compressed, there will be change in resistance. That change in resistance is given to the Wheatstone bridge. The output is taken from these two edges and it is connected to the output. Okay, this output will show that how much of deflection is occurred in the beam direction. Okay, so the change in resistance is equal to the deflection in the beam when it is elongated or compressed. So that elongation is that deflection will be shown in the output. Now the next topic we are going to see is stepper motor. So what is meant by a stepper motor? Okay, stepper motor is nothing but it will rotate according to the pulse given. Okay, so generally DC motor will rotate continuously whether in clockwise or anti-clockwise direction. If you use the stepper motor, it will rotate stepwise according to the given pulse. There are three types of stepper motor. The first one is variable reluctance. The first one is variable reluctance. And the second one is the permanent magnet. Third one is the hybrid stepper motor. Hybrid stepper motor. Okay, we'll see the first step how the variable reluctance stepper motor will rotate in stepwise. Okay, so in the center there will be a rotor. In the center there will be a rotor where these rotors are made up of teeth. And there will be the poles these are the poles A1, A2, and these are the poles B1 and B2, and this is the rotor, and this is the center one is the rotor. Now we'll see how this stepper motor rotates in steps in clockwise direction. Okay, so now we have four poles here A1, A2, B1, B2. Now if you give pulse to these poles according to that angle, the stepper, that is the rotor, will rotate. Now I will draw the table here, that is A1, A2, B1, B2, and the hexadecimal code. Okay. Now for rotating in clockwise direction, first I will give pulse to the A1, B2. First I will give input to the A1, B2 pulse, and B1 and A2 will be 0. That is A1 and B2. The A1 and B2 I will give input to these poles. That is input signal. I will give a pulse to these poles. The remaining B1 and A2 is 0. B1, A2 is 0. Okay. Next B2, A2. And then input signal to the B2, A2, and A2, B1 and A1 will be 0. Okay, B2 and A2. So this is B2 and this is A2. So for these two poles I am doing electrical pulse, and the remaining are 0. The third one, A2, B1. That is A2 and B1, other 0. Now I put to these poles. And finally B1 and A1. What is B1? This is B1 and this is A1. remaining these two poles are 0. That is, I am giving input so that it refers 1. If you are not giving input, that refers to 0. Okay. So when the input is given, these three poles attracts the teeth of the rotor so that the rotor rotates. That is, the teeth of the rotor and the poles will be will be in the same line. That is known as variable reluctance. Okay. So the teeth of the rotor and when the teeth is aligned in the according to the straight line of the rotor rotates. That is known as variable reluctance. Now, by coming to the export for 1001, it's nothing but 9. 09, and this one is 06, 05, and the last one is 08. If you give this hexa code, the stepper motor will rotate it clockwise direction. So this is the hexa code. If you write this program or this, if you enter this code in the microprocessor, the stepper motor will rotate it clockwise direction. And if you type 08, 06, 05, 09, it will rotate it anti-clockwise direction. So this is known as variable reluctance stepper motor. Now we are going to see the topic about pumps. What is meant by a pump? Generally, pump is a device which converts mechanical energy into hydraulic energy. Okay. So there are various types of pumps. Reciprocating pump. The second one is the centrifugal pump. Again, in reciprocating, you will have various types: single acting, double acting, single acting reciprocating pump, and double acting reciprocating pump, and single stage single acting and single stage double acting. So we are having multiple types. While coming to centrifugal pump, we are having single stage pump and multi-stage centrifugal pump. This diagram represents about the centrifugal pump. Okay, so these are the parts of the centrifugal pump. So this is known as impeller or vane. You can see the blade-like structure, that is known as impeller or vane. At the center of the pump, that is called as eye of the pump. So this yellow color represents the eye of the pump, and the eye of the pump is nothing but it will be in the drive shaft, that is the motor shaft. So this impeller blades will be in the driver shaft. Okay, the center of the shaft is known as eye of the pump. And next, the outside, that is known as casing. Casing is nothing but cover of the centrifugal pump. And when the pump, when the motor rotates, what will happen? The suction creates so that the fluid will be delivered to the outward discharge. Okay, now we will see how does it centrifugal pump works. So to this center of the centrifugal pump, the inlet pipe will be fixed. The inlet pipe will be fixed to the center of the centrifugal pump. When the motor rotates, what will happen? This impeller rotates. When the impeller rotates, at the center of the eye of the pump, there will be a vacuum. So the vacuum will create a suction through the suction pipe. So the water which is at the underground level, what will happen? So due to the suction at the eye of the pump, the water resists. Since the suction pipe will be filled up the vacuum, so it sucks the water through the suction pipe. When it is sucked, what will happen? So the blade rotates, that is impeller blade rotates at a high speed. So it pushes the water to move outside due to the centrifugal force. That is known as centrifugal pump. Since the water pushes due to the centrifugal force to move outside through the delivery pipe, so this pump is known as centrifugal pump. Now we are going to see about reciprocating pump, that is single stage, single acting reciprocating pump. So this is known as suction pipe. This is suction pipe, and this is the underground level of water. That is sump or underground level of water. So this is cylinder. This portion is cylinder, and this is piston. This is suction valve, and this is delivery valve, and this is delivery pipe. This is delivery pipe, and this is the discharge of water. And this, okay, so this is known as crank, and this is connecting rod. So this is connecting rod. And this is crank. So this crank will be connected to the motor, and the motor rotates, crank rotates. When the crank rotates, what will happen? This will move the connecting rod towards forward and backward. Okay, so this will move, it will reciprocate forward and backward. That is, when the crank rotates, okay, so this connecting rod moves forward and backward. This piston will be inside the cylinder. What will happen? Now we see the working principle of this reciprocating pump. When the piston reciprocates from left side to right side, so what will happen? This suction valve will open, this delivery valve will close. The suction will occur through the suction pipe, so that the water rises towards the suction pipe and it will enter into the cylinder. The piston moves from left side to right side, so the suction valve will open, the delivery valve will close. So the suction will happen at the suction pipe, so the water lifts towards the suction pipe and return into the cylinder. Now when the crank rotates, again the piston will move from right side to left side, so the water which is in the cylinder will move towards the discharge. At that time the delivery valve will open, the suction valve will be closed, so the water will be delivered through the delivery pipe to the overhead tank or to the required level of the discharge. Okay, so this is the working principle of reciprocating pump. Now if you see from the top level of the sump to the center level of the piston is called as suction head. So this is known as suction head. From the top level of the sump to the center level of the piston is known as suction head, that is HS. Again from the center level of the cylinder to the center level of the delivery, this is known as delivery head, that is HV. So total head from the sump level to the discharge, that is known as total head. That is known as total head. So the total head is equal to suction head plus delivery head. So this is the working principle of the reciprocating pump. Next topic we are going to see about engine. So what is meant by engine? Engine is nothing but where the chemical energy is converted into heat energy. Where the chemical energy is converted into heat energy, and the heat energy is converted into mechanical energy. Mechanical energy. Generally, where the heat is converted into mechanical is known as engine. Okay, so chemical is nothing but petrol or diesel. This petrol or diesel is burnt inside the engine, so that the heat is developed here. Okay, so again the heat is converted into mechanical, so the engine rotates. The engine rotates, that is mechanical energy. Generally, there are two types of engine. One is internal combustion engine, that is IC engine, and the second one is external combustion engine. So those are nothing but turbines. Turbines in power plants. Okay, now we will see about what is internal combustion engine. Again, while coming to internal combustion engine, there are two types, that is 2-stroke engine and 4-stroke engine. Again, this 2-stroke engine can be divided into two types. One is SI engine, that is petrol engine, or compression ignition engine or diesel engine. Again, in four-stroke engine, it is divided as spark ignition, that is petrol engine, or compression ignition or diesel engine. So CA is nothing but compression ignition, diesel engine, and this is SA engine, that is petrol engine or spark ignition engine. Now we are going to see the working principle of four-stroke diesel engine, or it is nothing but CI engine, four-stroke petrol engine or diesel. Now first we will see the parts. So this is known as crankcase, and this is cylinder, and this is inlet valve, this is cylinder head, this is fuel injector, generally FI, so this is fuel injector, this is exhaust valve, this is exhaust valve, and this is the piston, this is the piston, and this is the connecting rod or CR. So these are all the important parts of an engine. Well, coming to the working principle, we are having a four-stroke. So what is this four-stroke? The first one is nothing but suction. The second one is compression. The third stroke is nothing but power stroke or expansion. And the fourth one is exhaust stroke. What is this suction stroke? So these are all the four strokes of a diesel engine. The first suction stroke is nothing but where the piston moves from PDC to BDC. When the crank rotates, what will happen? The piston moves from top dead center to bottom dead center. That is known as suction stroke. Again, when the piston moves from BDC to PDC, that is known as compression stroke. That is known as compression stroke. During suction stroke, the inlet valve will open, air from the atmosphere enters through the inlet valve and it enters into the cylinder. Okay. Next, during compression, both the inlet valve and exhaust valve will be closed so that the air will be compressed. So due to this compression, what will happen? The air which is inside the cylinder, the temperature and the pressure of the air gets increased. So at the end of the compression stroke, the fuel injector will inject the diesel fuel. Okay, so that is compression stroke. The third one is power of expansion stroke. That is, the temperature of the air is sufficient for burning the diesel fuel so that the combustion of the fuel takes place. So it pushes the piston towards the bottom. So it moves from PDC to PDC. That is known as expansion stroke or power stroke. And the fourth one is exhaust stroke. So after combustion of the fuel, the cylinder will be filled with the exhaust gases. At that time, the exhaust valve will open, and the piston moves from BDC to TDC. It pushes all the exhaust gases towards the exhaust valve. So the exhaust gas will move through the exhaust valve to the atmosphere. So these are all the four strokes of a diesel engine. And next, there is one more topic that is known as scavenger. What is scavenger? Scavenger is nothing but cleaning of the exhaust gases. The inlet valve will open before the exhaust valve closes. At that time, the fresh air enters into the cylinder. Okay, it cleans all the exhaust gases so that no exhaust gas will present. So the fresh air will push all the exhaust gas towards the exhaust valve. That is known as scavenger. Thank you, students.